So what is this first in first come or first come first serve scheduling algorithm? The process are executed on the first come first serve basis. The newly created process are placed in the ready queue. It is placed in the ready queue. When new process is created, it is placed at the end of the queue, always at the back, always at the back. So the other name for this scheduling algorithm is also known as what? First in, first out. First in, first out. FIFO. Remember FIFA? You'll come to know this is FIFO, first in, first out. So what is first in, first out? The queue is called as first in, first out. You know queue? Because whoever comes in first, that will go first out. The scheduling algorithm is easily implemented. It is very easy to implement. But we have some drawbacks of first come, first serve. The performance of this technique is lower as the average waiting time for the process is high in this method. I'll tell you while teaching also. This method is non-preemptive. You know what is meant by non-preemptive? It will not come back again. It will not come back again. So that is one disadvantage. Because you know why? If you have to wait for its turn in the ready queue, like in the ATM, they have to wait for its turn in the ready queue. Like in the ATM, separate like if any old person comes also, no, they have to wait in queue. If any ladies comes also, no, they have to wait in the queue. So this is one drawback of your first come first serve. With high priority process, if it is there, they also has to wait. This process here, it is called as non-preemptive. Non-preemptive means it cannot come back to the processor again. Okay. The performance of the technique is lower. For example, so this is process P1, this is process P2, and this is process P3. For example, if P1 takes 10 minutes, if P2 takes some 50 minutes, can anyone tell me what is the waiting time for P3? How much time you need to wait? P1 take 10 minutes, P2 take 50 minutes. How much time P3 will need to wait?
60 minutes.
Is 60 minutes because the P1 is spending time in CPU 10 minutes, P2 is waiting in spending time in CPU for 50 minutes. Totally P3 has to wait for 60 minutes. So it is big problem, yes or no? The performance of the technique is lower as the average waiting time of the process is what? High in this method. If the average waiting time of the process is high, then this technique is very big problem. Do you understand what is meant by first come first serve? Because I'm going to teach the problem now. Do you understand? First come first serve means whatever the process comes first will execute first, and whatever the process comes next has to go back, So that's why this algorithm is also called as first in first out. First in first out. Here you are implementing queue. You know what is queue here? What is the drawbacks on preemptive? So I'll explain one example here. In exam they will give like this. They may give some real-time scenario also. We have to understand the questions, whether it is queue or whether it is first come first serve or it is round robin or it is priority or it is hottest job. You have to understand. So now this table is given. Consider the following process along with their burst time. Along with their burst time. This process, how many processes are there? Totally how many processes are there? Come on dear, tell me how many processes is here?
Three.
Three,
Three.
Mr.
P1, P2 and P3. So, burst time means how much time it takes to execute. What is the time given to P1?
15.
15. What is the time given to P2? 10. What is the time given to P3? 5. Okay. Now what it is given, calculate the average waiting time and turnaround time. Because see here, we are going to do this one. The scheduling criteria. Do you know the scheduling criteria? What we have seen here? Scheduling criteria. We are going to find out waiting time we are going to find out turnaround time. Turnaround time and waiting time we are going to find out, because we want to know which one is best. Because this criteria only, I told you, the performance of the system. The performance of the system depends on what? Depends on the scheduling criteria. See, when choosing any scheduling algorithm, which one should be maximum and which one should be minimum, like that. Okay, come here. Now, read the question carefully. What do you want to calculate? What do you want to calculate? I want to calculate average waiting time. I want to find out turnaround time. Now, the process is given in the order. What order is given? Which one comes first? Which one comes first?
Process 1.
One, but then
Process 2.
what happened? Where is that? Okay, no problem. If you have network problem, just after that you can see my video. Okay, then process 1, process 2, and then
Process 3.
process. So the first process is P1. All the processes are arrived at the same time, and they arrived at the same time. Okay, see here. Now all are in the same time, arrived at the same time. Process P1, P2, and P3. Here also P1, P2, P3 are arrived at 0 millisecond, 1 millisecond, and 2 millisecond. Here, if all processes are arrived at the same time, okay, I'll go with this one first. So the problem will give an average waiting time and turnaround time. What you need to do here is, first one, the case one, you need to draw the Gantt chart. You need to draw the Gantt chart like this. In the order P1, P2, the arrival process is represented like, it is same like first come first serve, because already if all persons comes in same time, see, we go with P1, P2 and P3. P1, P2 and P3. You understand what is the meaning here? See, P1, P2, P3, all the processes are arrived at what? Same time. See, for example, in the ATM, if all three persons comes at same time, who will be given? Who will be given the process? That is the meaning here. So I will go with P1, P2 and P3. No problem. You can go with P2, P1 and P3 also. No problem. You can go with P3, P2 and P1, because all processes arrive at same time. If you change this one, then you need to change this also. If you start P3, then P5. If you start at P2, then 10. If you start at P1, then you need to start with 15. Come to here. So what is this Gantt chart? Gantt chart means like flow chart. You know flow chart? Flow chart of the system. Here also we have the Gantt chart. So first process I start with what? First process I start with, see, I'll draw here. First process I will start with P1. Always starting time will be what? Starting time will be, come on dear, tell me. Starting time will be always 0, right?
0. Yes.
Yes.
What is the time given for P1? What is the time given for P1?
15.
0 to 15. 0 to 15. That's what I put here. So P1 is 0 to 15. So process P1 is over. Yes or no? Process P1 is over. Completed or not? 15 minutes is over for process P1. That means process P1 is executed. Yes or no?
Yes,
Yes.
mister.
ما تطلع يوم راسك يدور.
What happened? Why are you fighting? Who is fighting there? What is this process P2? So process P2 starting time is 15 because the ending time of P1 is 15. The process P2 starting time will be 15. How much second it will execute? What is the time given? How much time for P2? Here, process P1 time is 15. Process P2 time is what?
10.
Okay. Like how we did 0 to 15. Now I will add 10 into this because the process time for P2 is 10. So 15 plus 10 is what? What is 15 plus 10? Here, what is
25.
25.
25.
right? 25. That means P2 will execute up to 25 seconds because its starting time is 15. 15 plus 10 is 25. Next P3. The starting time for P3 is what? Oh God. What is the starting time for P1?
0.
What is the starting time for P2?
15.
What is the starting time for P3?
25.
Why 25? Because it is the ending time of P2. Do you know why it is 15? Because it is the ending time of P1. The ending time of P1 will be the starting time of P2. The ending time of P2 will be the starting time of P3. It is like same how you are standing in queue in ATM. If first person is completed, you are waiting up to that and your turn. And third person will be, you need to add the first two person. Okay, the starting time for P3 is 25. What is the time given for P3? What is the time taken for P3? Burst time. What is the burst time for P3?
5.
5. So I will add 5 here. Time will be what? 30. I'll do one thing here. I will take one cell. What is the time now? Just wait for 5 to 10 minutes. See, I'll draw the Gantt chart here. So I'll take P1, P2, P3 like this. Okay, so this is my process P1. This is my process P2. This is my process P3. Or I'll use my wait. 1 minute. What is that? So here. So first process is P1. Next process is P2. And next process is P3. So the process P1 starts with 0. So it is time is given as 15. So 0 to 15. So the P2 10, add 10 into that. So you will get 25. And for process P3, the starting time is 25. I am adding 5 into that. So it will be 30. So the Gantt chart is given like this. See here. Where is the Gantt chart? Yeah, Gantt chart. So this is the Gantt chart 0 to 15, 15 to 25, 25 to 30 because you are adding 15, 10 and I. Do you have any doubt in drawing the Gantt chart? Do you know how to draw the Gantt chart?
Yes, mister.
Yes, please reply. Else I will repeat. If you ask me to repeat, I'll repeat how to draw the Gantt chart. Because always the process starts with P1, P2 and P3 the same time. So I start with P1. You know why I put P1? You know why I put P1 here? You know why I put P1? Because starting time is what? P1. What when it starts? It starts with 0. You know why I put 15 here? You know why I put 15 here? Because of this. Because of burst time. The P1 burst time is 15. So 15. The next process is P2. Okay. So what is that? The P2 burst time is 10. So 15 plus 10. It is 25. Next is P3. So P3 burst time is 5. 5 plus 5, it is 30. So this is how you need to draw the Gantt chart. This is how you need to draw the Gantt chart. See, even in Excel also I can draw it. Like I will start with 0, 0 to 15. Okay, so 0 to 15. And then 15 to what is that? 10, right? So it is 25. And next 25 to 5. So it is, I take here 30. So it will be very easy for you to draw it. If you want, you can take screenshot for this. They use snipping tool. When asked in exam or anything, just take this screenshot and then copy, paste it in. Like Gantt chart. Finish class. Anything you can do it. It is easy. Understand? Okay.
Yes,
Fine.
Mister.
I'll stop now. Next one is what? So from the Gantt chart, I'm going to find what? I'm going to find the what I need to find. I need to find the waiting time, right? So I need to find the waiting time and I need to calculate the turnaround time. So waiting time for P1 is what? What is the waiting time for P1? Tell me, is P1 is waiting? Allah, tell me, dear, is P1 is waiting? If P1 goes first, is it waiting?
No, Mister.
P1 time is 0. Waiting time will be 0. What is the waiting time of P2? The waiting time of P2 is 15 because that is the ending time of P1. So the waiting time for P2 is 15. What is the waiting time of P3? The waiting time of P3 is 15. So sorry, 25 because that is the ending time of P2. So the waiting time for P3 is 25. What is the turnaround time? You know what is waiting time and what is turnaround time? Turnaround time is just put the ending time of each thing. See here, P1 ending time, P2 ending time, P3 ending time. So what is the ending time of P1? What is the ending time of P1?
0.
No, ending time of P1. Ending time of
15. 15.
what is the ending time of P2?
25.
25.
What is the ending time of P3?
30.
30.
So you know waiting time and you know turnaround time. See here, using this where is that? Where is the paint? Okay, now I have this one. So how to find out the waiting time for P1? The waiting time of P1 is 0. The waiting time of P2 is 15. The waiting time of P3 is 25. Okay. Waiting time of P1, P2, P3 is like this. And the turnaround time for P1 is 15. The turnaround time for P2 is 25. The turnaround time for P3 is 20. It is very, very simple. Nothing. First, last. First, last. First is waiting time. Last is turnaround time. You okay? As of now. So, and you know, the waiting time for P1 is 0. The waiting time for P2 is, here it is wrong. It is 15. It is 15. Waiting time for P3 is 25. So just divide. So 40 divided by, it is correct, total is correct. 40 divided by 3, it is 13.33. So average waiting time is 13.33 and turnaround time is 15 plus 25 plus 30, you'll get 23.3 milliseconds. So like this you need to do it. Okay, I'll stop. Right. Answer the attendance, please. Who is absent? Okay, I'll take the attendance from here. Okay, dear. Thank you so much. Have a great evening. Bye bye.
Bye bye, Mister.
Goodbye, Mr.